Hello, my name is Richard McMillan, and I am the composting operator at the CBRM Composting Facility in Sydney, Nova Scotia. I'm just going to give a brief overview of why we use a SCADA-based program system to control our composting plant. So here is an introduction to our composting facility VTS SCADA system program. Our VTS SCADA system program runs our composting facility. We can monitor the environment inside each tunnel. So, for instance, our composting facility has 7 composting tunnels, and if you can look up here on the panel, there's 7 tabs. That'll show each tunnel and what the environment is like inside each tunnel with the composting. So our plant runs off of 2 phases, phase 1 and phase 2. So if you look up here, we are in tunnel 1-1. And these are all parameters that you can see. I'm circling them here. That's with inside the environment of the tunnel. So we can monitor temperatures, pressures, RPMs, airflows. So what we have to achieve in each of the phase 1 tunnels is a temperature of 57.5 degrees in order to achieve pathogen kill. So if you see, this tunnel here is 1-1, and we have material inside. There are sensors on the roof of each of the tunnel. There's 1, 2, 3, and 4, and they're giving us temperature probes of what the temperature is inside the tunnel. So right now in tunnel 1-1, we have an average temperature across the whole surface of 55.7. So in order to achieve pathogen kill, we need to have 57.5. So we're just about there. But also what's going on in the tunnel is we have a lot of airflow going through underneath. So if you can see with the mouse here, our airflow comes through a dedicated electric fan and motor, which basically just forces air, if you follow the mouse, underneath each tunnel. So you can see the air going down this path, and it's going, here's our circulation fan. So the air goes underneath the tunnel. The air activates bacteria in that composting and creates heat, and that's what we're looking for. So with that being said, we can change that circulation fan anytime we like. We have, here's our flow going through it. We have how fast the fan is spinning. It's at 90%. We have pressure, and we have our inlet temperature. So after the air has passed through each tunnel up underneath, we have to exhaust that air. We could circulate it back through. If you follow the air through here, it comes back down through the underneath. But we can also exhaust it out to our scrubber. So there's also temperature probes that tell us our oxygen percentage. We have pressure on the outlet going to the exhaust. We have our wet and dry bulb percentages. We also have sprinklers that are piped into the composting each tunnel. So for instance, if the tunnel seems to be a little bit dry, we can add a little bit of water, because water is essential to making good compost. It's a fine line between how dry and how moist it should be. So if we find that a tunnel has a little bit too much dry, we can add a little bit of water to it to kind of even out the balance. So each tunnel has this same overview. So there's all kinds of tabs on this left-hand side that gives us information what's going on inside the tunnel. We have composting temperature, inlet temperature, oxygen, relative heat exhaust. We can add fresh air to the compost also. There's a lot to look at when you're making compost. So I'll pull up another tab. Here is our water overview. So when making compost, you make a lot of water, excess water, and a lot of the water is dirty water. So we have to take that water and actually we put it in these 3 tanks, but we have to filter it. So if you can look on the screen here, the water comes from dirty water from the tunnels and the biofilter. So all the water that comes out of the composting on phase 1 side and phase 2 side, but mostly phase 1 is where a lot of the dirty water comes from, it'll come to this dirty water tank. Once it sits in this tank and it gets to a level that we need to pump it out, a pump will come on, pump it up over this screen, and this will take out any solid material, and it'll fill this tank. Once this tank gets to a level that we want it desirable to pump out, a pump will come on and fill up this storage tank. So within this panel, you see we have a lot of water in this tank. There's 1.83 meters right now, but a lot of times we'll have to get rid of this water. So this is water that's been filtered. The solids has came out of it, and we have to send that down to a treatment facility. So periodically, once a week, we get rid of a lot of this water because this is excess water. Now, this is also set up. We call this our intermediate tank. So it's water that has already been filtered. So a lot of times, if we find that our composting is getting a little bit too dry, we can add water through this tank. Now, we can only add water on phase 1 side tunnels because it's technically not. We have to achieve pathogen. So if we had a lower temperature, but it seemed to be a little bit dry, we can add dirty water to that side. Phase 2 tunnels require potable water because that's already achieved pathogen kill. So we don't want to introduce any bad bacteria to that pile. So phase 1 tunnels, which is tunnel 1-1, 1-2, 1-3, and 1-4, can use this dirty but cleaned water to help make the compost moist. The phase 2 tunnels, phase 2-1, 2-2, and 2-3, cannot use this water because it's already achieved pathogen, and we have to add potable water if we find that those tunnels are requiring more water. So there's a few tabs that you can look at here, which telling these are transmitters that are in each of the tanks that are telling us the level, how much water is in each tank. There's RPM sensors that are telling us how fast the motors are turning and how much pressure is on the pumps. And we can select each of these tabs and make changes to the overall process of how we want our water to work. So for instance, here's our sprinkler system that each tunnel has sprinkler systems to add water. We can water queue phase 1. We can set up a time when we would like to have water being put on the compost. So I'll pull up our scrubber and biofilter tab. So this page shows where our exhaust air and our fresh air ends up going. So when we're making compost, it requires a lot of air to create that heat that we need on phase 1 and phase 2. So if you think about it, it's a lot of dirty air that's going into that. Once we add the air to the bottom and it filters through the compost up to the top and goes out the exhaust damper, it's really dirty air, so we can't send that air out to atmosphere without treating it. So if you look here where I have the mouse, where our pink line is our exhaust air. So each of these tunnels, there's 7 tunnels, phase 1 tunnels, phase 2 tunnels. They each have their own dedicated exhaust damper. So when the exhaust leaves each of those tunnels, if you follow this path with the mouse, it comes down and it comes into this section here, and this little square box is called our scrubber. So it's basically a square box that accepts all the air from the tunnels, and it cleans it by passing it over filter media. It's called Q-Pack media, and it's square media that basically the exhaust goes over it and it attaches itself to the media. So the air comes through this section, goes through our scrubber, and goes out to our biofilter. Our biofilter is basically a carbon bed that when the exhaust goes into the carbon bed, you see there's two beds. There's bed number 1 and bed number 2, corresponding with how we have phase 1 tunnels and phase 2 tunnels. So the air exhausts over the top of the carbon bed and is being pulled down through the carbon bed by our exhaust fans, which are located outside right here. So our exhaust fans are pulling everything from the tipping floor, which is where we place all of our material, green feedstock we call it, and our tunnel system. So every bit of air that is being used inside the plant and fresh air that is being pumped in also on the tipping floor is being exhausted through these ID fans, these exhaust fans. So the exhaust fans pull every bit of air from the tunnel and the tipping floor through a scrubber system, which is cleaning it, and then back out through a carbon bed, which gives it the final cleaning before it sets it out to atmosphere. And if you can look here where the mouse, this is a stack that is extended up into the sky, and then it just releases it out there. So you can also there's all kinds of tabs here that you can tell what's going on in that environment also. These two numbers here, this is our airflow to the biofilter. So they're very important to figure out how much we register in CFM flow. So that's telling us how much airflow is actually leaving the scrubber and going into the biofilter. This number here, this APTO1, is our process air pressure. So we have it in a water column. That's our negative pressure. We always have to achieve a negative pressure on the plant in order to make sure that the air is being drawn from the tunnels and the tipping floor out through this scrubber. It's very important to keep this at a negative vacuum, because if that was in a positive, all the exhaust, the dirty exhaust and potential for H2S, ammonia, certain gases, that could be released out to the atmosphere before it gets to the biofilter. So we have to make sure that this is always in a negative to have a vacuum on the plant. We will pull up our HVAC overview. So this is just another HVAC overview that's showing kind of where the air is going. This area here that I'm squaring off is basically our tipping floor. So we call it the receiving hull. So this is giving you showing you the biocells, which is tunnels 1 to 4 and 2 to 3. We have heaters that are out back of the composting facility that we have to achieve a little bit of heat on the tipping floor for the winter months in order to keep the tipping floor above -degrees. So we have to have that, we like to have it at about 8 degrees. That just helps us for the material that is being taken in on the floor, that it's not frozen before it goes in the tunnels. So if you can look at, there's all kinds of tabs here again that's showing you the environment that's on the tipping floor. Right now we have a tipping floor temperature of 17.2 degrees, just because it's always warm here. The tipping floor, if it's warmer outside, we always have a higher temperature on the tipping floor. We have this line here, this whitish colored line, that's just showing you that we have fresh air going into the tunnels. It's not showing any RPMs because it doesn't communicate with our computer system, but it is on. Again, you can select different tabs to change any parameter that you like. Most times the system is in an automatic, but we can also run things manually. So we can set the computer up to kind of work automatically on its own, that it does its own set of parameters, but we can also make changes to them ourselves by manually controlling them. If we want something to do, if we wanted to do something specific, we can make changes to that. So basically, that's a good overview of what we do, why we use the computer, because there's an environment in each tunnel that has to be monitored. We do daily checks, writing all of these numbers down, which are most relevant to our process. So again, we just basically, we have 4 phase 1 tunnels. So here's tunnel 1-1, here is tunnel 1-2, tunnel 1-3, and tunnel 1-4. We call them our phase 1 tunnels, and all we're doing in those tunnels is basically filling material in it, closing the door, turning a fan on and forcing air underneath the pile and exhausting that air. We're trying to achieve a temperature of 57.5 degrees, and we have to leave it in those phase 1 tunnels for at least 9 to 11 days. After that 9 to 11 days, we can then take it out, put it in these phase 2 tunnels. Here's phase tunnel 2-1, tunnel 2-2, tunnel 2-3. Once we fill those tunnels, close the door and turn the fan on, we have to leave it in there for at least 17 days if it's in phase 1 for 11. We have to achieve a total days of 28 over the whole process between phase 1 and phase 2. So with that being said, we're constantly changing, monitoring, and assessing what's going on in the environment in each of those tunnels, because we have to kind of hit parameters that we need to achieve in order to move the tunnels before we can actually take them out. And like I said, we can do that manually, but it's also set up to work on like an automatic. So for instance, once this temperature hits a 57.5 degrees, we have a block up here that says our phase. So right now we're in phase 5 heat up. Once it achieves that 57.5 degrees, that phase will change over to phase 6 it's called pathogen kill, and it'll have a whole set of parameters that it wants to achieve. And then once it achieves those parameters, it'll change over to the next phase. Once they're finished doing all the phases, we can then take it out. So that's just an overview of why we use our SCADA-based system. It's basically there to control everything that's going on in the tunnel and to achieve everything that we need to achieve in order to take it out so that we can screen it and cure it and be ready to give away.